This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
All right, welcome everybody. Thank you for coming tonight to the Miegunyah. I've just been told that is correct pronunciation. Miegunyah Distinguished Visiting Fellowship Seminar. So to begin with, I would just like to acknowledge that we are here tonight gathered on Wurundjeri land, and the university sits on one Wurundjeri land as well. And it's important that we always remember that we are working and living on unceded land. And I would like to pay my respects to elders, both past, present, and emerging. So tonight I'd like to welcome distinguished Professor Phil Hulme, who is visiting here as a Miegunyah, distinguished visiting fellow. So just a little background about this program. This is an annual program that is set up through a generous gift from the Wade. I'm not very good at this pronunciation. The Wade family that enables outstanding researchers from international locations all over the world to spend an extended period of time here at the University of Melbourne. And the purpose of these visits is for these academic greats to contribute to the university's academic, intellectual, and cultural life, and also have some time working closely with researchers in their similar fields. So with that, I think I will pass it over to Andrew, who will introduce Phil.
Thanks, Margie. I'm not going to read all of the beautiful things that I wrote about Phil as part of the Miegunyah application or on the flyer. I assume you've read this because that's why you're here. Instead, I would prefer to share with you some key Phil facts that will prepare you for the extravaganza. Phil was born in Beirut, and he was an unusually beautiful baby. He grew up in France, and then he grew up again in Suffolk, and then he did a PhD at Imperial College after doing an undergraduate there, and then a postdoc in Spain. Phil is now the very distinguished professor at Lincoln University, and I'm proud to say was recently awarded the New Zealand Ecological Society Ecological Excellence Award, or in Māori, Te Tuhutaio, which is Chief of the Environment. Yeah, which is awesome. Wait, no, Guide of the Environment. I made that chief bit up. Phil is delighted to be here, and he'll tell you so, and his favorite color is green. Please join me in welcoming Phil Hulme. He's going to talk without...
Yeah, no mime.
So you're going to have to,
There you go.
It's Phil.
There we go. It's back.
Welcome back, Phil.
Thank you very much, Andrew, for that fantastic introduction, and thank you also, Margie, for your introduction. Of course, I'd like to thank the Wade family for the support through the Miegunyah Fellowship, which brought me here after a very long period of hiatus, thanks to COVID. Andrew and I got together prior to it was just after the COVID, and we were planning for this event, but border restrictions frustrated us in multiple different ways. So I'm very pleased to be here, and I'm very happy with the hosting by COBRAS, and I look forward to a week more with the team there and learn more about the work that we're doing here. So today, I know we all try and move on from COVID, but when you're working in biosecurity, it's something that hangs over you somewhat in terms of the lessons that might be learned. And so today I want to try and use our kind of joint experience of COVID as a means of trying to understand how we might improve the way we approach biosecurity. So the structure of my talk, initially what I'd like to do is, for those of you unfamiliar with the whole concept of biosecurity, is just to introduce you briefly into some of the key issues that underpin the challenges in managing biosecurity threats. Then I'm going to use that to discuss a bit more about the parallels between more general biosecurity threats and pandemics, and then move that on to identify at least 4 key areas where I think we can learn from the response globally to the pandemic that we could translate to better biosecurity. So hopefully you're familiar with what biosecurity is. There's a number of definitions, and my favourite is the New Zealand one because it's the shortest. And it simply says that biosecurity is the exclusion, eradication, or effective management of risks posed by pests and diseases to the economy, environment, and human health. So it's quite straightforward, quite broad though in terms of what biosecurity encompasses. It's not just border biosecurity, and it's certainly not just agricultural biosecurity, which sometimes we feel that under a government context, that is what biosecurity stands for. And why do we need to study it? Well, examining this figure shows the black line is the number of new records of alien species somewhere in the world. And you can see that probably since the early 1800s, the number of new records of alien species around the world have more or less steadily increased, with a slight peak during the 1929 recession and during the Second World War. And that has outstripped and outpaced, in many cases, the rise in international trade, although at the moment it's tracking very closely with international trade. But the message here is that this is an ongoing problem of a global scale, and it doesn't seem to be getting any easier or less over time. And each one of these alien species being introduced into a new country potentially poses an economic or an environmental threat. So biosecurity is critically important to manage that potential risk. So what is biosecurity actually attempting to do? Well, here in this animation, I want to talk a bit more about the biosecurity continuum, where a species that is native in one region is then introduced into a new region. So a species from Europe is introduced into Australia, it establishes as an alien species, and then it becomes invasive and spreads beyond the original point of introduction. That's invasion biology. Biosecurity implements on top of that the management protocols that are needed to try and prevent or mitigate that process. And these include pre-border factors, such as pre-export inspections, pest risk analysis, import risk analysis. Interventions at the border, including inspections, on-arrival treatment, pathway risk analysis. Post-border interventions, which manage the post-border risk, such as pest and disease hotlines, also post-border diagnostics, surveillance and rapid response. And then it moves on to pest management. Once the species is widespread, it's often about species control and containment, modelling the dynamics. Now, this is all linked back, often to a global scale, by issues such as market access, also things such as the acceptable level of protection and area freedom surveillance. So this whole cycle is what really is the biosecurity continuum, from border to border. And underpinning a lot of this is the whole concept of risk and risk assessment. Now, broadly speaking, risk is a function of the likelihood of a consequence occurring. So here we have consequences which might be negative, such as yield loss or biodiversity loss, which range from minimal to massive, and then we have likelihoods that range from very unlikely to very likely. And in an ideal world, we could map a range of invasive alien species onto that matrix and have a better understanding of what risks those species might pose. So here, coming from New Zealand, top there is the Queensland fruit fly, a bugbear of ours, but also there are species that probably from both New Zealand and other parts of the world are unlikely to be introduced again, things like mongooses. We've done that in Hawaii and a number of other places. I don't think anybody's going to come in at Sydney carrying a mongoose and get away with it. So although its consequences would be massive, the likelihood of it getting in is actually quite small. So what is likelihood? Likelihood deals with the pathways, the way that the species are introduced. And there are a number of pathways that you could imagine. One is where the pathways through a commodity. So the species itself is being introduced, and they could be released as a game animal. They could escape captivity, such as many of the animals that have escaped from fur farms, or they could be a contaminant in a grain crop, for example. Other organisms can come in as a vector, such as a stowaway, so they might be hull-fouling organisms. And then others are dispersed through corridors, such as some of the canals that have been built around the world, particularly the Suez Canal, but also some can disperse from one part of the world where they're non-native, where they're alien, to another. They arrive, they then have to reach the appropriate habitat, they reproduce, and then they spread. So those are all the aspects that we need to understand when we're trying to predict or quantify likelihood. Consequences are very diverse as well, and here just a brief selection of them. So predation on native species, herbivory on our native plant species, parasitism, hybridization, competition, impacts on hydrological flows, increased flammability, and also the eutrophication of habitats are all the types of impacts that alien species might pose. And so again, we need to try and understand the magnitude of these impacts, which in itself is a challenge. Once we have this kind of knowledge, we try and put it into a risk assessment that captures something of the likelihood. And here we want to know something about can the species enter the region? If it does enter, can it establish? And can it then spread in the area? And then we also want to quantify the consequences. So, for example, can it be managed in the area? What kinds of impacts will it cause? So in a figure like this, it looks like risk assessment is a relatively simple linear process. But it's complicated by the fact we need to include biological parameters, particularly aspects of the species biology in terms of its dispersal strategies, its ability to spread, also its ecological properties that might lead to impact, and also the socioeconomic aspects, such as trade, both trade internationally, but also movement of species within a country due to commerce. So then risk assessment becomes quite a complex beast. And it's made even more complicated by the numerous drivers of invasions. If we look around ourselves, we can see that many drivers are deliberate. So we have species introduced for biofuels, or for forestry, or for angling, for agriculture or horticulture. So those species come in through that route. But then there are other aspects that are much more social, such as poor governance, or humanitarian aid, or civil conflict, particularly wars like the one in Ukraine at the moment, are undeniably going to bring in new species to a particular region, because no one's really caring about biosecurity when there are shells coming in at your border crossing. And so this leads to a great deal of uncertainty on our drivers. And a group of scientists got together and identified that actually, although they work a lot in biological invasions, they're incredibly uncertain about many drivers. And in particular, things like cooperation, legislation, and other international agreements, the implications of those drivers on invasions are poorly understood. Similarly, awareness and values of the human population about invasions and how they might influence the whole process are poorly understood. And similarly, the effectiveness of invasive alien species management are poorly understood. So what this leads us to is a situation where we have two axes, one of likelihood, one of consequence, where we either have a lot of knowledge or we have little knowledge. And within those axes, ideally where we want to be is where we have a lot of knowledge about consequences, a lot of knowledge about likelihoods, and there we can undertake our standard risk assessments, where we work with familiar systems and we have known invasive species. Where we have little data or knowledge on both of these, we work in an environment called ignorance. And that's really where a lot of biosecurity sits. But no one's ever going to fund a centre for excellence in biosecurity ignorance. So we all tell ourselves that we're sitting much more into the top corner there. Where we have some knowledge of the consequences, but not about the likelihood, we work in an environment of uncertainty. And where we have very little knowledge of consequences, and a lot of knowledge of likelihood, issues can be very ambiguous because our values of what causes an impact can determine how we appreciate the risks. So that's the environment we work in, and this is how we have to try and deal with risks. And my feeling and the structure of this talk is that something happened a few years ago in that we had COVID arrive. SARS-CoV-2 virus arrived, which we had very little data or knowledge, very little on either the consequences or the likelihood of that virus and what its trajectory would be globally. But in the last 2 years, progressively knowledge has pushed that, not all the way to risk. I'm not that optimistic because there's still uncertainty in terms of long-term COVID. There's still ambiguity as to whether some of the policies that we adopted were the right ones or not. But nevertheless, the knowledge that has preceded the first arrival of COVID has been pretty impressive. And so what is it about that whole system that has enabled us to transition from almost complete ignorance to a state where we're far more knowledgeable about the risks of that virus? And so what I want to try and do now is to illustrate what it is about COVID that has helped us understand a bit better about biosecurity. So the first thing is, there are parallels between biosecurity diseases and biological invasions. Charles Elton wrote probably the classic book of biological invasions, and in 1958, and he identified Spanish flu as a clear case of a biological invasion, with its initial introduction from the United States into Europe in 1918, and then the subsequent second wave that spread the virus around the entire world. So the affinity between pandemics and invasions has a long history. And scientists have recently rediscovered this and promoted the idea that COVID and invasions should be, that pandemics and invasions should be much more closely aligned in terms of the communities working on these topics. And I looked at Google Trends, and actually Google Trends showed that as the epidemic began, or the pandemic began, the COVID pandemic began, searches on Google were picking up the term biosecurity very frequently. So people were becoming increasingly aware about biosecurity primarily due to the COVID pandemic. Of course, that died down, but there was a burst of interest in biosecurity relating to that pandemic. And of course, we can see parallels in how we respond to some of these biosecurity threats, with people in white suits looking at COVID in Shanghai, but also in the case of Myrtle Rust, people dressed in very similar ways to protect and manage the problem. So visually, the issue of invasions and pandemics have many parallels as well. And from a biological point of view, we can see parallels between the transport, introduction, establishment, and spread of an invasive organism and the exposure, infection, transmission, and epidemic spread of a disease. And so again, all these parallels suggest that we should be able to use something like COVID-19 as a model to better understand biosecurity more broadly. So my thesis tonight is, why was the SARS-CoV-2 response so dramatic? The first one is that there was a strong link to human well-being and viewed by many members of the public as an existential threat. We also had advanced tracing and diagnostics of infectious individuals that helped us manage the problem. There was also incredible accelerated integration of science, of the science community across animal and human health, also diagnostics, epidemiology, public health, as well as economists and social scientists. The whole community came together very quickly to deal with this issue. And finally, the global perspective of the pandemic had an overarching international regulatory framework which facilitated a global response to this problem. And what I want to do is to illustrate that if we can get these different measures integrated much better into the broader biosecurity field, we might be stronger at responding to the threats in the future. So let's start off with just thinking about biosecurity and human well-being. One of the issues that invasion biologists like doing is coming up with big numbers of the costs of invasions. And here, recent data from the Globe say that between 26.8 and 162.7 billion US dollars per year is the cost to manage biological invasions globally. Those are big numbers. And here they break it down into different species groups. So Aedes mosquitoes, the cumulative cost over 40 years is around $150 billion. Big numbers. But for me, those big numbers, once you get over $1 billion, I can't really visualize what 2 billion or 3 billion or 4 billion, let alone 160 billion. So basically, beyond $1 billion, it's meaningless to me. And I suspect that for many people, big numbers, they plateau. After a while, they don't have much impact. And so I think these kinds of numbers aren't very useful. However, on the other hand, an image such as this has a much greater impact in terms of telling people what the risks might be. Now, the Zika virus and the microcephaly that ensued was something that the world knows about. But did they frame it in the issue of biological invasions? They didn't. But they should have done. Zika virus was an invasive pathogen in Brazil. But more than that, it was transmitted by an introduced mosquito, a yellow fever mosquito. And so therefore, it was a double whammy. An introduced pathogen on an introduced vector that caused it. So basically, this image reflects biological invasions. It was a biosecurity issue. And yet, the messaging from these images were much less about biosecurity and much more about public health. We need to make sure that the messages about invasions and biosecurity associated with well-being are much clearer. Now, for diseases, it's probably quite easy to try and link invasions and pandemics and human well-being all together, because there are a number of situations where introduced species, so avian species, are fundamental to human well-being, particularly through diseases, either by the pathogen being invasive, a vector such as a mosquito or biting fly being invasive, a reservoir host in the environment being also an invasive species, or there are even situations where invasive plants provide microhabitats that facilitate things like tsetse flies or mosquitoes' survival. And so there we can link things through quite clearly to a human well-being cost in terms of human health. But what about all the other invaders that we know about? How do we try and solve those? Well, the issue is we can try and map them onto the UN Sustainable Development Goals. We don't do this enough, but if we look at invasions, we can see that they impact a number of SDGs, including hunger, food security with one case. We also have life, biodiversity, life on land, life on water, climate. We also have, here we have economic growth as well, that impact all of these sectors. And yet we don't communicate very well that these impacts of invasions on these sectors have ramifications for human well-being. And I think if we were able to do that, the appreciation of the public of the role that biosecurity plays in their well-being would help us manage the problem more effectively. The next aspect is the tracing and tracking for biosecurity. Now, this is something that we no longer do, but at one point we were all doing it. We were all scanning ourselves as we were going around buildings, etc. We were being mapped and monitored quite regularly, potentially by Big Brother, but nevertheless, we were still actually undertaking a number of scanning tasks. And we had faith that the organizations that were collecting that data understood about privacy, and thankfully they weren't telcos that would otherwise release those data. But we can understand that a lot has occurred in the whole tracing approach that could be translated more rapidly to biosecurity. So for example, I had the unpleasant experience, and maybe some of you had as well, of filling in the Australian Digital Passenger Declaration. I wasn't impressed by the whole process, but I was impressed by the technology in that you could actually encompass a lot of your personal information through an app online, including the RFID chip on your passports. So you could accumulate quite a bit of information remotely prior to actually traveling. And now it's no longer being used. That might be a relief for some. But you just thought that that technology could be better applied for biosecurity issues. At the moment, when you come into Australia, you still have to fill in these paper forms. And often there aren't any in English, so I've had to fill some in Spanish or French or whatever's going, because you can't get the English forms because they've all disappeared. Why not have it as an app system? Now that could help capture that information pre-flight, might help triaging at the border, but also it captures the body of information of who's coming into your country. And also, you're not limited by these bits of paper in terms of the questions you could ask. The questions could be dovetailed to ask specific biosecurity related questions that in themselves, over time, could show shifting values of people coming into the country. So I think that's an opportunity that we're missing at the moment, and we could probably do more of. But we also have a GPS tagging. GPS tagging, apart from those of you who have to wear ankle tags, and if you're in the audience, some apologies for that. But if you're not wearing those ankle tags, then you may be less familiar with the types of GPS technologies that are out there for monitoring cattle, but also things like containers. All that information is being gathered, but there's actually no systematic way of accessing that information to actually monitor biosecurity issues effectively. So that data is being captured, but not necessarily always for a biosecurity perspective. And scan, as I mentioned, we've all used our smartphones to scan entries into buildings, etc. under COVID. Scanning is still occurring in a biosecurity context, but that information is lost into the ether. There's no way of monitoring all this information. Why not have a centralized means of capturing biosecurity information through scans for farm biosecurity that we can give us a national perspective of who's moving around and what threats they might pose. So I think that the tools exist for better tracing, particularly for pre-departure screening, and capturing baseline data on the passenger pathway. GPS tags can be increasingly used both for commodity movements as well as other aspects of biosecurity, including the vectors. And the public are familiar with signing with their QR codes. We shouldn't lose that enthusiasm of people to sign in. And if we leave it for too long, people won't want to go back to the whole process of downloading an app and signing into things. The next thing is biosecurity integration. Biosecurity affects multiple sectors. Here are some images from New Zealand. We have the pea weevil being controlled, fruit fly, we have myrtle rust, we have Mycoplasma bovis, we have Chilean needlegrass, and we have didymo. A wide range of taxa, a wide range of environments. Biosecurity is functioning across all of those. And some biosecurity threats are cross-sectoral, like the red imported fire ant, damages crops. It also attacks native biodiversity, it impacts human health, and it impacts livestock health. It's a cross-sectoral problem. And it's not the only one of the biosecurity threats that we face, that they are cross-sectorial. However, much of our research is sector-specific. Here's some examples of the cooperative research centres in Australia, all targeting particular sectors. And the same is with Plant Health Australia, Wildlife Health Australia, Animal Health Australia. These bodies tend to look inwards into their sectors as opposed to looking across their sectors for opportunities for cross-fertilisation. And I think that this is a limitation, because as a community we should be more integrated, because there are certain opportunities for critical mass in a number of different areas that we're missing. And if we look at the research globally, we see that most research, and each of these large circles is reflective of the amount of research on human health, environmental health, animal health, or plant health. You can see that most research in the world is working on human health. These are logarithmically scaled, so the circles are, the big circles are even bigger than you might imagine. But you can see that plant health, some area that a lot of us work in, very little research there. And the links between the fields show quite clearly that plant health is left out of things a little bit, but also that most links are through to human health. And that triangle right there, animal health, environmental health, and human health, is what is widely known as One Health, where those sectors are working increasingly closely together to deal with issues that pertain to all three areas, and particularly in relation to human well-being, whereas plant health is left out of it somewhat. Now, when we look at the system, this is the One Health system that links animal health, environmental health, particularly in relation to zoonotic diseases, and human health together. So really about pathogens being transmitted from wildlife hosts or from livestock to humans. That is the broad aim of One Health. But is that biosecurity? Is that sufficient? My feeling is not, because plant health is critically important to human health as well. Invasive alien pests and plants reduce the quantity and the quality of food, so they challenge food security, which is a direct risk to human health. And mycotoxins from invasive alien crop pathogens can have major problems for livestock. So already plant health should be brought into the perspective. And of course, introduced animals such as pigs, etc., can have major impacts on our crop production. But being someone who studies a lot of weeds, I had to put weeds into this. Weeds are also important in the system. They produce allergens that have a direct impact on human health. Most of the people who get hay fever in Australia and New Zealand are responding not to native pollen, but to introduced pollen. Invasive alien plants are also habitats for vectors of animal diseases, and several of them are toxic to livestock. And then finally, there's a link between environmental weeds and plant health in terms of the weeds reducing yields of crops. So this is my view. We have the One Health in the middle, but what I call One Biosecurity, it captures a much broader picture of what we need to manage in terms of biosecurity. And that without understanding all these different elements, we're missing out on how we handle future threats. So why do we need biosecurity, One Biosecurity? But the first thing is, we need to understand things that affect across these different sectors. We're just looking at one single sector, we'll miss out important aspects of different sectors that impinge on our own systems. One Biosecurity bridge these different sectors and hopefully allow greater foresight. It may be that vets do have a good idea about plant health, or plant health entomologists might have a good idea about human health. We just don't access that information very well in our siloed systems. And many invasive species do impact, either directly or indirectly, different sectors. And if we don't study all the sectors, we might miss important impacts that otherwise could cause problems in the future. And then maybe the future societal challenges such as climate change, urbanization, and land use change are going to dramatically change all the threats to these sectors. And so understanding the bigger drivers as a community of biosecurity scientists is important, as opposed to individually in each group. So moving on finally to the global perspective on biosecurity. Now, biosecurity is very much a sovereignty issue. We tend to look at our national borders and protect them. But actually, most invasive species are not restricted to a single country. They're global issues. And here we have, from the 100 worst invasive species in the world, how many continents upon which they're invasive. And down here we have things like starling, feral cats, mosquitoes, that are global invasive species. And over here we have things like the comb jelly, the Australian possum, which is only found as an invasive species in New Zealand, and the brown tree snake down at the other end. But for the majority of invasive species, they occur on multiple continents. And you think that, why didn't we stop it when it was just on one continent? Why are we allowing these species to spread across multiple continents? And that's because we tend to deal with biosecurity at a sovereign state level as opposed to a global level. And we should be treating things like the bronze bug, again, a species that's come from Australia and spread around the world, the eucalyptus plantations, very similarly to a pandemic SARS-CoV. Because it's the same process, it's just working on a very different timescale. The species are spread across countries and then popped around the world. Here, over a series of years, there in a series of months. And so that's the difference. We tend not to view invasions as pandemics because of the timescale across which they occur. And if we look at spread rates, here are your invasive species, you can see the spread rates in kilometers per year are much lower than the pathogens. But look how fast the human pathogens are spreading. They're spreading at least 1 or 2 orders of magnitude faster than invasive alien species. And so because they're happening so quickly, we visualize that change in our own timeline. Whereas a lot of alien species are spreading across a similar kind of spatial gradient, but over a slower time period. So it's not as impressive to us that the species are spreading very quickly. And there are some examples where species are moving pretty quickly around the world. The fall armyworm would be one, but even then, that's only over a couple of years. It's not over a couple of months, such as the many of the viruses that shock us. So again, just because it's a slightly slower process doesn't mean that a global perspective isn't useful. So for COVID, the international health regulations, which are manned by the World Health Organization, were critical for managing the issue at a global scale. And the international health regulations require countries that are signatories to ensure they have a decent surveillance system, they have specific guidelines to assess a public health event, they have to report any events that could be of potential pandemic risks, and they have to respond to public health risks. And this is mandated by the World Health Organization. And this is why, despite early on some misgivings as to the reporting from China regarding the virus, that the system of reporting and recording was pretty effective throughout the pandemic. We don't have anything like that for biosecurity. Imagine if we did have something like the international health regulations that would require countries to report quite quickly on any potential threat they could see as becoming of pandemic risk. Maybe we'd be able to react faster rather than relying on species actually ending up knocking on our door. So I propose that, being an optimist, I propose that there's opportunity here where at a global scale we can view invasions as a pandemic process, and that all we need are new risk assessment tools that go beyond national borders. Rather than saying this species is a risk to our habitats, we need to say, well, what's the risk that if this species establishes in Australia, Australia will become a hub for this problem elsewhere in the world? We tend to just focus on our country as opposed to the consequences of us mismanaging the situation and leading to problems in future parts of the world. We need a stronger regulatory instrument to address biosecurity threats at a worldwide scale. We also need to mobilize capability across the world. The Burmese python in Florida is a major problem, but they actually employed Burmese experts to go to Florida to actually teach them how to catch pythons. New Zealanders are famous around the world for going around and helping people kill rats on islands. There's expertise that you might need to deal with your problem. It may not be in your country, it's somewhere else. We don't mobilise that national capability. We also need to be able to characterise the threats or the threat index of different countries around the world to understand how vulnerable they are to problems. Because a vulnerable country could potentially become a hub in the future for future pest outbreaks. And in the long run, have a multilateral biosecurity convention that's responsible for biosecurity governance. Now this is the way I kind of planned it out. I'm not going to go into too much detail, but we're talking about realistically over a decade to undertake these things. First, getting one biosecurity on the agenda, providing evidence, then designing implementation tools, and then moving it on, even to trying to get it ratified by the United Nations. We've got to think big about this, and how realistic this is, I'm not sure. But unless we start trying to put some clear implementation plans forward to deal with this issue at a global scale, we're never going to achieve anything. And these organisations are all touching that area. They could be quite protective of their own patches, which is one of the great challenges. But these organisations have part of this role. What we need to understand is whether they want to share that role or another body should take over the whole process. So there's a whole issue here where we can try and bring together these large organisations to try and deal more effectively with biosecurity. Okay, so to finish up, let's look to the future. What does the future hold under this kind of one biosecurity framework? Well, as I mentioned, we need one biosecurity because the challenges we face are going to be common to whatever biosecurity threat we have, whether it's a human well-being threat, an environmental threat, an agricultural threat. We need to understand these issues together. So urbanisation, urban areas are hotspots for emerging diseases, they're entry points for pests, and there's often a high urban natural interface, which means species spread from urban areas into the natural environment, causing environmental changes. Climate change, often an improved climate for pests, ecosystems become less resilient, and extreme events all will affect disease as well. And agricultural intensification facilitates pathogen spillover, facilitates pest spread, and fragments native ecosystems that then become more vulnerable to invasion. And we looked at trying to forecast the kinds of things that workers in biosecurity should be focused on in the future. And we see a number of things along this invasion continuum from introduction to impact, but we can see things such as invasive species denialism. So you may not be familiar with that, there's a pushback that actually pests and diseases are something we just have to learn to live with, or in some cases their benefits outweigh their risks depending on the sector you're in. There's going to be increasing resistance there, as well as issues regarding changes in our value systems. But there's also issues where we'll have changing agricultural practices, new techniques such as eDNA, which might be a panacea because we can detect organisms very quickly, but then we detect thousands of organisms we didn't know were there in the first place, and we have to start thinking about what risks they pose. So there's a whole number of things that we need to deal with in the future. And I think the only way to deal with this is a way that it crosses the different sectors, because each of these issues is not specific to plant pests or animal pests or human pathogens. They're relevant across all sectors. So, to summarise, as the largest biosecurity response ever mounted globally, we must learn from the SARS-CoV-2 pandemic. And because that's the only way we can secure human, animal, plant, and environmental health worldwide. Biosecurity threats should be framed much more in the language of human well-being. And I think that's a great challenge for us. It doesn't mean over-egging the pudding and trying to say that everything is going to be an existential crisis, because that would be just as bad. But when we see pests that are impacting agriculture, we say, oh, this is going to cost X million to control. But what if we said, if Capra beetle comes in, it's going to add 10 cents to a loaf of bread, or much more values that people might actually sense, as opposed to an arbitrary big figure. Rapid development of tracing technology is something I think will definitely change our way we manage biosecurity, but it needs to be integrated. And there's already large data sets held by governments that aren't integrated. We need to ensure that the next stage of biosecurity has an integrated platform for this big data. One biosecurity, a pet idea of mine, I still feel is important to bring these different communities talking together. Rather than trying to fight for different slices of the funding pie, working together will mean we'll actually have much greater success. And a longer term goal is that we really do need to have a global strategy for biosecurity as opposed to national strategies. And no organisation at the moment does this effectively across all sectors. And if we don't do that, I think we're always going to be facing pests and diseases coming at our borders and having to deal with them kind of in a reactive way as opposed to a much more strategic way. So, thank you very much for your attention, and I'll finish now.